All right, let's talk about one of the most powerful and honestly kind of misunderstood technologies out there today, machine learning. We're going to demystify this whole thing by going on what I like to call a builder's journey, really starting from scratch, from the ground up.
I mean, seriously, have you ever stopped to think about it? How does your phone just know your face? Or how does a streaming service queue up the perfect next movie for you? It feels like magic, right? Well, the tech behind it is exactly what we're gonna unpack. Stick with me, and by the end of this, you'll totally get the blueprint for how this stuff is actually built.
Okay, so every great project, every building, it all starts with a single spark, right? An idea. For our journey, that first spark is just getting our heads around what it even means for a machine to learn. So, what are we really talking about here?
This idea isn't exactly new. This definition from Arthur Samuel goes all the way back to 1959. And the key phrase here, the real game changer, is without being explicitly programmed. Think about that. Instead of a programmer sitting there and writing millions of if-then rules, we're building systems that can figure out the rules on their own. Now that was a revolution.
Okay, so fast forward to today, and we've got a slightly more technical definition from Tom Mitchell. But don't worry, it's super simple when you break it down. Just remember E, T, and P. Let's say we want to teach a computer to spot cats in photos. The task, T, is, well, identifying cats. The experience, E, is us showing it thousands, maybe millions of cat pictures. And P, the performance, is just how good it gets at spotting cats in pictures it's never seen before. So if its accuracy goes up, the more photos we show it, then boom, it's officially learning.
All right, so we've got our idea, our spark. What's next on the builder's checklist? You gotta get your materials, right? And in the world of machine learning, there is one raw material that is king. It's more important than anything else. Data. Seriously, it's the absolute bedrock, the foundation of everything. And I mean everything we're about to build.
And this leads us to what is basically the first law of machine learning. And you've probably heard it before. Garbage in, garbage out. And listen, this isn't just some cutesy saying. It's the stone-cold truth. If you feed your model junk, messy, incomplete, just plain wrong data, you're going to get a junk model, period. The quality of what you build is 100% tied to the quality of your materials.
And get this number is kind of crazy. Up to 90%, 90 of the time and effort on a machine learning project isn't the cool, sexy part of building the model. Nope, it's the tedious, unglamorous, nitty-gritty work of cleaning and preparing the data. This right here is what makes or breaks a project. It's like the digital version of having to sort, sand, and prep every single brick by hand before you can even think about building the wall.
So what does messy data even look like in the real world? Okay, let's take a look. This is a classic example from the famous Titanic dataset. You can see the problems right away. Look under age and cabin. You see those empty spaces? Those are missing values. Total headache. And then look at rows 3 and 4. They're exactly the same. That's a duplicate. A machine can't learn anything useful from this kind of chaos.
And here's the aftershot. So much better. It's beautiful, right? Look, that duplicate row is gone. The missing age, it's been filled in, probably with something smart, like the average age of all passengers. And that cabin column that was a total mess, we just dropped it. It wasn't worth the trouble. Now we have clean, pristine, structured material. Now we can finally start building.
Okay, we've got our big idea, we've got our clean materials. It is time to open up the Builder's Toolkit. Now, inside this toolkit, there are a ton of different, complex tools, for sure. But honestly, most of them boil down to doing one of two fundamental jobs. Let's check them out.
So, it all comes down to the question you're trying to answer. On one side, you've got regression. This is your go-to tool when you're asking how much or how many. Like, how much is this house going to sell for? You're predicting a specific number. On the other side, you've got classification. This is for when you're asking which one. Is this an email spam or not spam? Is this a picture of a cat, a dog, or a bird? See the difference? How much versus which one. Simple as that.
All right, now this is where the real magic starts to happen. We're about to take this super abstract idea of a machine learning and make it totally concrete. We're literally going to watch our model try to draw its first blueprint, mess it up, and then figure out how to fix it all by itself.
So here's our setup. We've got all these data points scattered on a graph. Now, they could be anything, but let's just pretend the horizontal axis is house size and the vertical is the price. Now, you and I can look at this and see the pattern instantly, right? As the size goes up, the price tends to go up. The big challenge, the whole goal here, is to get the machine to see that exact same pattern and draw a line that sums it all up. So what's the model's first move? It literally just guesses. It throws a random line onto the graph. And as you can probably tell, it's a pretty terrible guess. I mean, that line doesn't capture the pattern at all. But here's the crucial part. That's totally okay. Getting it wrong at first is part of the plan. The most important thing isn't the first guess. It's having a way to measure how wrong that guess is.
So how does it do that? How does it know it's wrong? Well, it uses a clever little tool called a cost function. The easiest way to think about it is like a score in a video game. It calculates how far away the line is from every single one of those little blue dots, adds all that error up, and gives you one single number. A really high score, that's a bad guess. A really low score, that's a great guess. And the goal of the game? Get that score as low as you possibly can. Drive it down towards 0. Okay, so now that it has that score, the model makes a tiny little tweak to its line. It nudges it a bit to try and get a better score. And look, the line moved. It's a little closer to the data now. It's getting warmer. And it just keeps doing this over and over. Make a guess, get a score, make a tiny adjustment, repeat. This whole process of taking small, intelligent steps to lower your error score, that is the heart of machine learning. And for all you nerds out there, a super common way to do this is with an algorithm called gradient descent. Just picture a ball rolling down a hill. It's always trying to find the lowest point. And after doing that thousands, maybe millions of times, ta-da! Learning achieved. The model has finally found the one perfect line that has the lowest possible error score. We call it the line of best fit. It has successfully learned the hidden pattern in our data. It took our raw materials and turned them into a working, predictive blueprint.
So, let's recap. We've laid our foundation. We've prepped our materials. We even know how to use the basic tools in our toolkit. Now comes the really fun part, the payoff. Let's take a look at the absolutely mind-blowing masterpieces that are being built today using these exact same principles.
First up, we gave AI the power of sight. It all started pretty simply, with just classifying an image, is this a cat or not? But then it got way more advanced, with object detection, finding all the cars, people, and stop signs in a video feed, which is obviously what makes self-driving cars possible. And now, we're at a level called segmentation, where the AI can understand the purpose of literally every single pixel in a picture. It's incredible.
But it didn't stop there. Then we taught AI how to be creative. I mean, we have models called GANs that can dream up completely realistic faces of people who have never existed. We have AI that can take your silly little sketch and turn it into a photorealistic image. And of course, you've seen things like DALL-E, right? You just type a sentence, any wild sentence you can imagine, and it generates a piece of stunning original art from thin air.
And finally, we taught AI to understand us, to speak our language. This is the stuff you use every single day. It's in the machine translation that lets you talk to anyone in the world. It's the voice in your smart speaker that can tell you the weather or play your favorite song. And it's the helpful chatbots that can answer your questions at 2 in the morning. AI is literally weaving itself into the very fabric of how we communicate.
Wow, okay, we've covered a lot of ground, right? From just a simple idea all the way to these world-changing applications. So let's bring it all home. Let's boil this entire complex journey down to one simple, super powerful formula. This is the secret recipe for building basically anything with AI.
And here it is. 3 simple steps. Step 1, you need a goal, an idea. What problem are you actually trying to solve? Step 2, you need data. High-quality, clean, raw materials to build with. And step 3, you pick the right model, the right tool for the job, whether that's regression, classification, or something even fancier. Goal, data, model. That's it. That's the blueprint for everything.
So what's the big takeaway here? We've just walked through the fundamental recipe for machine learning, and hopefully you see now that it's not some unknowable magic. It's a process. It's a builder's journey. And once you know the recipe, once you have the blueprint, well, that empowers you to ask the most exciting question of all. Now that we know how to build, what are we going to build next?